So we're looking at your data. Looking at the reefs. We took out the part that you saw. I dropped all the spaces in between so I could import in easily. It's in a CSV file. We changed the names of location from semi and ubiquitous to multi-section just so it's there. You have a lot of interesting names for species. Cool. And this may be something that you want to take a look at. This is called hill numbers, and it's a way of quantifying biodiversity based on what you've seen and what you expect to see with additional sampling. I'm not sure the data are set up correctly. And let me actually go check one thing, see if the data are set up correctly. So, yeah, we could do it this way to give you an idea that this may be something you want to take a look at. Based on your question, is how the diversity changes relative to surface type and right?
Material.
Right? Okay. And numbers. I mean, you actually want diversity and overall numbers. So, yeah, this will work. And this will work. And this will work. And these are no. Surprised by that. This will give us a quick little. Yeah, this will give me just a quick thing to show you what this means and how it works. And this is good. So, these are measures of biodiversity using something called hill numbers. What they allow you to do to sort of your point is they allow you to identify different indices of diversity from species richness, Shannon, and Simpson relative to what you saw and what you expect to see with continued sampling. The line that is solid reflects what you actually recorded, and the line which is dotted reflects what you would expect over time based on the number of species you saw, how quickly you found them, and such. It works very nicely. One of the things that this would allow you to do is then make comparisons between surface types and other things, in addition to sort of more traditional methods. So like you're probably going to do some standard like chi-square type contingency table type thing. I use this surface, I got this many organisms.
Yeah.
This goes a step beyond that. The other thing that actually may be of interest, frankly, since we're here, is you may also be interested in ordination plots or multidimensional scaling, which allows you to look at whether you have different types of communities emerging based on material type. So this is actually data that come from Santa Cruz, and it's looking at reptile and amphibian communities relative to habitat, and the greatest source of variation is the x-axis, secondary is the y-axis, and along the x-axis the primary and the secondary are the same. So for the greatest source of variation, the communities in the primary forest and secondary forest are exactly the same. Pasture ends up being a little bit different. Along the secondary source of variation, we start to see separation between all three habitats. So there are differences here, but really on the primary level, on the most important factors, they're essentially the same. Based on your data, yeah, I could see that actually being very much what you want to look at. Do you get one type of community emerging when it's face up, another type of community emerging when it's face down? Do you get one type of community that emerges when it's grooves, another type that emerges with ridges and grooves and ridges and cups? Does that conceptually make sense to you?
Yes, I think so.
Okay.
Are those good names, by the way? Grooves, ridges, cups, or is that?
Oh.
Could I be more concise?
I'm of the opinion, two things. One, any name is appropriate so long as you define it clearly. Now, I will be voted down many times if I have a silly name, but there's nothing that strikes me as silly there. You would just describe the fact that you have combinations of 3 different surfaces. Every single tray has grooves within those surfaces. Trays with only grooves are identified as grooves. Other trays have both grooves and ridges to those surfaces. In those cases, they were divided as grooves and ridges. And then third class created a third topography of cups within those. So you just literally define it. And
Okay.
as soon as you define it, you are good.
So I shouldn't just call it like treatment 1, treatment 2.
No,
because
I find that
that's-
less
yeah.
clear.
Okay.
Much less clear. Frankly, I think it's a very fair question. I like descriptive categories because they just help the reader and you understand things. Otherwise, what you're doing is it's called one, and then you have to go back over here and try to
Yeah.
remember what one is. It's like an acronym, and I hate acronyms for the
Right.
same purpose. You are going to have to change things like black blob film,
Yes.
but that's a
Working on the ID separately, yes.
yes, that's a separate thing. And that would actually be hard because all you got to do is go in here, and for everything called arc, you just use your filter. You grab arc, and then you can change the name to whatever you want. But do these two approaches make sense to you? I mean,
Yes. those-
kind of makes sense to me quite a bit. And then the third thing that I would probably do with your data is I would just do almost kind of a measure of biomass, but how many organisms do you see? And for that, I would do really a contingency table. Association. I don't think I showed you association plots, did I?
I don't know. Doesn't sound familiar.
We can come there when you're ready to come there. So then there's a few things. In terms of your code here, we actually already have VCD extra. That's your association plots. You have INEX, which is your hill numbers, and the ordination. Oh, I'd have to find it. Ordination CTA, but I don't remember right off the top of my head, and I definitely don't think it's psych. So I think you're basically ready. Okay. You've done this part. You've done this part. This part, no big deal. Your issue, you're getting an error, and your issue for the error is you didn't tell the computer what variable to relevel. So you said,
Yes.
make a variable called location, relevel it, but what you had was just Q1. So you're saying relevel variable Q1. Well, you don't have a Q1. What you
Okay.
have is location, and then you have each of the categories within locations.
Gotcha.
And because they're a category within the variable, we put a quote around it, which helps our know that. Same thing down here. You had surface, you had relevel, but then you had flat. And it was like, I don't know what flat is. I don't have flat as one of my variables. So we say relevel surface, and then we put up the conditions for those. We run summary of that. The reason you get these others down here is because it only shows you the first 6. And since you have more than 6 categories, it just says there are others.
Okay.
If you want to check what those categories are, what I generally do is just $, and then pick what I want. Let's do species. Okay. And then that will give you the summary of those species, arc, black bob. And you got a lot. You've got a lot of sort of rare things. You have some stupid common things, oysters.
Another problem I had, which I'm noticing right here, I have doubles of things, and I can't figure out why, because they're spelled exactly the same.
Yeah, 100% totally fair, completely annoying. So this is where I go back to Excel, and I do something with all my data. I would generally just copy and paste the exact same thing. They all said 4.1, but I noticed oyster. We don't have to do that for everything, but I'll just show you it as an example. In the case of oyster, I go over to species, I get rid of that, I go down to oyster, And then
How do you get it to jump down to the bottom right away?
Oh yeah, sure. I hold Shift, Command if you're using a Mac, Control if you're using a PC, and then I use the down arrow.
Nice.
And that would just automatically go a series that are consistent with what you previously had. So if they're occupied, then it will do a series of occupied things. If they're unoccupied, it will do a series of unoccupied things. Whatever it is so far, and it'll go to the endpoint. So then I save this and get rid of that. Okay. Save it. Go back up here. And this is something that I definitely do in Excel. And then I reload it. Okay. Right. Right. So let's do this. We're going to do series df plus 9. And now we only have the one oyster.
Nice.
It's dumb, but it does save you a tremendous amount of time. And since there's only one, that was weird. And generally what it is you have an extra character in Excel that you cannot see. It's a hidden character.
Yeah, that's what I was thinking. I was like, is it a space that's just like at the end? I don't know. It actually happened with a bunch of them.
Did you see how I do that? So we have
Yes.
tunicate. So what I would do is sort of go through, and a lot of times with research, we have filamentous green algae. We have red algae. Oh my God, you actually have a lot.
I know.
You have, okay, so what I would almost kind of do is go to that CSV, and you kind of almost just do them one at a time. It doesn't matter which one you pick so long as they're all the same. Obviously, if you have one, it doesn't matter. But do you see what I'm doing?
Yeah.
Something's happened, something's weird. That's what I do. Okay, so I can let you do the rest of those?
Yes.
Okay. But you do need those. I'm going to save this. Let's open a new project. Right, okay. Okay, this will work. So boy, this is unpleasant. But it's not hard. But it is unpleasant. Walk me through this. I need to understand here. Okay, so you have inoculation date. You leave them out for 50 days. Are these really all the same plates? I mean, that's all the same plate? You had 434 organisms on one plate?
Well, so it gets even more difficult than that because what I've realized is there's so much on there and it's all growing on top that there's no way I could ever count every single thing on the plate. Which,
Are you leaving them out for too long?
well, we actually were thinking we're not leaving out for long enough because we're seeing a lot of like these little things.
How big are these plates?
They're like, yeah, think like exactly that size.
You saw 434 things on something this large?
Yeah. I'm looking at it under a dissecting scope, and a lot of the stuff is really, really small. So it's amazing.
Really?
Yeah. There's like, and I mean.
And you only put out 3 plates?
We had sets of 3 plates going out at a time, and I think I have like 3 or 4 sets of 3 plates each that have gone out and come back. And they were going out for about a month. This is the longest set, went out. I think this is the first one, and it went out for 50 days, but the rest of them went out for about 30. But we were thinking about doing quarterly sampling instead. So.
Cool. Okay. Okay. I'm not sure. Okay. I'm not sure this will work. I do think this will work. Because what this is about sort of resampling. And you could call a plate a sample. That's totally fair. But I can't think of you processing 100 plates. How long did it take you to process this one?
One, at the moment, takes me like an hour or 2.
No. You can sample 434 organisms in an hour? Do you know? Okay, hold on a
2
second.
hours.
No, hold on a second. Okay, so how many minutes are there in an hour? There are 60. And how many seconds are there in a minute? There are 60. You got 3,600 seconds in an hour, and you can do 343 organisms, which means, okay, 343. Oh, I can't do my math. Oh, right. Oh, right. It's taking you were able to identify something within 11 seconds. Every 11 seconds, you can identify
Maybe
a
I
species.
was underestimating. It was probably more like 3 hours per plate.
I was about to say, because if you were going to go with 2, then I'm only giving you 20 seconds. And you know what happens when it's 3, right? It's 30 seconds.
Yeah. So I see a lot of the same stuff over and over and over again, and what I'll do is in one square section, I'll see like 20 acorn barnacles, and then I'll just copy and paste 20 in that quadrant.
I got you there.
So
I got you there.
Do multiple at the same time. So it's not like every single one. Like, there's an acorn barnacle. There's another one.
Okay,
So-
there are a lot of ways to analyze what you are describing. What I'm a little terrified for you is how
Yeah.
much data processing there is.
I know.
In terms of how you're recording it, it is fine so long as your descriptions are the same for each individual species. This I don't think it is viable, but the other stuff I do think is viable, and contingency tables out the frickin' yin yang
Yeah.
are incredibly viable. I don't think you need to modify your data structure yet, and the ways that you would need to modify it are not that freakishly difficult. And there's a lot of tools both within R and Excel which can make that happen easily.
Okay.
Does that give you some direction?
Yes.
Are you sure?
Yes. You had also mentioned count data.
You got tons of count data.
Yeah. So that might be another thing for me to look into.
This is count. How often you see something.
Yeah.
And you have count relative to, well, here, I'll give you an example using this. Okay, let's go. This is, we're going to make this easy. I'm going to replace that. Just to illustrate the point, not to. Okay, so let's go with species and location and location. Okay. as an example, here are your oysters. And if you look across here, they seem to be distributed in certain locations. Like if we take the top third, and we take the bottom third, if we take the middle third, more. Now, what would make me very, very comfortable is number 5 was the most. Because I'm assuming it goes, if this is your plate, it goes one of two ways. 1, 2, 3, 4, 5, 5, 6, 7, 8, 9. Or it goes 1, 2, 3, 4, 5, 6, 7,
Yeah,
8, 9.
it goes
Either
across.
way, 5 is the center.
Right. The unfortunate part about 5 though is that there's a big hole right there
Oh, that's interesting.
for plate installation.
That's interesting. Okay, so
Can I use that one then? Should I ignore it?
count it for right now. You might have to control for it statistically, and there may be some ways to control for it statistically. But
Okay.
that's where count can actually get you some information.
Yeah.
You can have you have side, right? And let's get rid of that. And A means something and B means something. What does A and B mean?
Yeah, front and back.
Oh,
I
dear
went
Lord.
in, I changed them because you said something about it last time, but I missed the first page of the Excel.
Okay.
So I went back and changed it.
Yeah. But now you understand why I don't like 1, 2, 3.
Yes.
Okay. This is actually looking like you have something going. Most things are settling out on
Although
the front.
part of that is because I only looked at B for 4.1 and not 4.2.
And that's why. But you see where count data can come up
Yes.
with, because it can show you whether you have uneven distributions. And there's also ways of modeling out, given different environmental parameters, where would you expect to see something. So you can even flip the question. Instead of saying where do you see something, you can say, given all these parameters, what's the likelihood it's going to settle?
Yeah.
So given all these parameters, what's the likelihood that oyster's going to settle? And these can be done in a variety of different approaches. So you have it.
Awesome.
Continue working with the data.
Yes.
Okay? Should I send this back to you?
Yes, please.
Okay. Can I stop recording?